Now we are going to solve that LCR series. This LCR series basically covers the course learning outcomes 3, and that's which basically hits the program learning outcomes 12 of the graduate attributes, which is lifelong learning. Here is the governing equation: L di by dt plus Ri plus Q by C is equal to E. This is formulated because of Kirchhoff's law. Now substituting the values, it will looks like that 0.5 times d square q by dt square plus 6 dq by dt plus 1 by 0.02 q is equal to 20 sine 10t. You should remember that the charge, how to get the current is basically the rate of change of the charge. So using that techniques, first we will be able to find the charge q, which we can easily find in terms of solution of the given differential equation in front of you. Now coming to that things, you write like that in the standard form. Then you write it in the operator form like d square plus 12d plus 100 times q is equal to 40 sine 10t. This is basically f of d and q is equal to f of t, which is a linear differential equation of higher order with constant coefficients. Now the auxiliary equation constructed, which you have already learned how to construct, is m square plus 12m plus 100 is equal to 0. And from that auxiliary equation we get the roots minus 6 plus minus 8 iota, which are complex. The complementary function then will be constructed in this manner: e raised to power minus 60 times c1 cos t plus c2 sin 8t. We are done with one part of the solution, which we obtained from the auxiliary equation. The second part of the solution is to find particular integral, and particular integral depends on the right side function, which is the source function, and our whole solution depends on the right sides. So here is the case of sinusoidal. It means sin is occurring over here on the right side. So we need to find particular integral in this way: 1 over f of d times f of t. Now 1 over f of d means 1 over d square plus 12d plus 100 times 40 sine 10t. So what is the procedure? The procedure is that simply you are going to replace d square by minus a square. Here it means minus a square means you are going to replace d square by minus 10 square. Minus times square of 10. It means you are going to replace d square by minus 100. So it will looks like that, whatsoever after substitution, it will looks like that particular integral will become 10 by 3 times 1 over d times sine 10t. 1 over d is used for integration, so the integration of sine 10t is minus cos 10t over 10, which is after simplification will be minus 1 over 3 times cos 10t. Hence the solution will looks like q of t is equal to e raised to power minus 60 times c1 cos 8t plus c2 sin 8t minus 1 over 3 times cos 10t. This is the solution for the charge at any time t. Now we will look at a solution for the current as well, and then we will be eliminating the arbitrary constant c1 and c2. Since you already know that the current is basically the rate of change of charge, so I'm going to differentiate q with respect to t to find I, which is given in 2. Then q is 0, it means the charge is 0, the rate of change of charge is 0, it means the current I is 0 at t is equal to 0. So by this way we can find the arbitrary constant c1 is equal to 1 over 3, and similarly C2 is equal to 1/4. Using the condition Q is equal to 0 and I is equal to 0 at T is equal to 0, and that can be obtained easily from the equation 1 and 2. Hence, after substituting the arbitrary constant value C1 and C2, Q of T will looks like that, and similarly I of T, which is the current, will looks like that, which are both the charge and the current at any time t. Then when you simplified the current I of T, the simplified version will looks like I of T is equal to minus 5 times e raised to power minus 60 sin 8t plus 10/3 sin 10t. So this was the solution of the interesting problem occurs from the applications of linear differential equation of higher order with constant coefficients.